Magandang araw! April Marcas po, ang inyong pretty ate sa Edtech Unit. Alam ba ninyo na may webinar o online training session ng Edtech Unit tuwing Sabado? Ang araw na ito ay nakalaan para sa ating mga mahal na kaguruan upang turuan sila ng mga bagong kaalaman at kakayahan sa paggamit ng makabagong software at applications para sa pinaka-epektibong paraan at lubos mapaghusay ang kanilang paraan ng pagtuturo. This is also a refresher session for our beloved teachers to enhance their skills in technology. Every Saturday, we will conduct webinar sessions for teachers about the use, advantages, and relevance of different blended learning software applications. Ang webinar seryeng ito ay magsisimula ng alas 9 ng umaga hanggang alas 12 ng tanghali para sa morning session. Magsisimula naman ng alauna at magtatapos ng alas 4 ng hapon ang afternoon session. You can watch us in our DepEd Edtech Unit Facebook page, Educational Technology Unit YouTube channel, DepEd Tayo, and DepEd Philippines. Kita-kits tayo tuwing Sabado!
Magandang araw! Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng ICT sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Magandang hapon po sa lahat, lalong-lalo na po sa ating mga senior high school learners and parents who are watching our live stream of our ETUlay online tutorial. At pa-shoutout din po sa aming Regional Research Coordinator ng DepEd Region 8, Ma'am Jeneline Daya, and to our Regional Learning Resource Coordinator, Mr. Joy Biha. Good afternoon po, Ma'am Jeneline and Sir Joy. And also, I would like to greet din po ang lahat ng mga research teachers na nanonood sa ating session ngayon. Live na live po tayo sa DepEd Edtech Unit FB page at DepEd YouTube channels. Alright? At magandang hapon din po sa lahat ng ating online viewers. Hello po and welcome to our ETUlay tutorial session. Jane Wency, Micah, J. Isidto, April, Paolo, Beatriz, Valerie, Charlie, Isame, Maria Gloria, Julia, Stacy, Julianne, Lorenzo, Christine, Wilfred, Renan. Okay? Muli ako po si Tutor June at samahan niyo ako class as we learn very important topics for inquiries, investigations, and immersion. And today's exciting session will lead us to understand our topic on Quarter 4, Week 3, which is on data analysis techniques. Specifically at the end of this tutorial session, you are going to apply the appropriate quantitative data analysis technique to be used in the given problem. And for the information of everyone, we are basing our tutorial session today with the presentations of Sir Chris Anthony R. Sabino, a senior high school teacher in the division of Romblon, a Region 4B Mimarupa, and Sir James Pedrera from Alang-Alang National High School, Division of Leyte, Region 8. To begin, I would like you, class, to perform this preliminary activity entitled Classifying Techniques. What you're going to do in here is that you are going to classify each word showing the different data analysis techniques commonly used in research. You are going to classify which of them relates to quantitative or qualitative research. Then write quan if it relates to quantitative research, and qual if it relates to qualitative research. Again, write quan if it is quantitative and qual if qualitative. For now, I want you to observe first and study the words flashed on your screen. That is to know which words relate to quantitative or qualitative research. And later, when I'm going to mention each word or each data analysis technique, you have 5 seconds to write your answers in our live stream's comment section. And also, please do not forget, class, to indicate the item that you are answering. All right? Are you ready? Let us begin. Number 1, frequency counts. Is it quan or qual? Again, number 1, frequency counts. Is this word or analysis technique relates to quantitative research or qualitative research? Julian, Hazel, Maria Gloria, Stacy, all answered quan. That is correct. Quantitative. Number 2, mean. Mean, is it quantitative or qualitative? And you are correct. Number 2 is for quantitative. Beatrice, April, you are correct. How about number 3? Narrative analysis. Is it quan or qual? All right. Julian answered qual. Andrea also answered qual. That is correct. Narrative analysis is a qualitative analysis technique. How about number 4? Variance. Is it quan or qual? Jane Wency answered quan. That is correct. Very good. Okay. Number 5, discourse analysis. Is it quantitative or qualitative? Beatrice answered qual for number 5. That is correct. Discourse analysis is a qualitative analysis technique. For number 6, content analysis, is it quan or qual? Raf Radores answered qual for discourse analysis. How about for content analysis? Number 6, Jean Kenneth, Isa May, Maria Gloria answered qual. You are correct. Content analysis is a qualitative analysis technique. Number 7, percentage. Is it quan or qual? Jean Kenneth answered quan. For number 7, Hazel Rose also answered quan, as well as Maria Gloria, Jane Wency, Micah, and Raf Radores answered quan. That is correct. Percentage is a quantitative data analysis technique. How about number 8, thematic? Is it quan or qual? Jean Kenneth answered qual. That is correct. Thematic is a qualitative analysis technique. Number 9, t-test for dependent samples. Is it for quan or qual? Number 9, John Vergabas answered quan. Okay, as well as Julian, Wilfred. Number 8, Wilfred answered qual. JR, quan. Isa May, Andrea, Julia, Hazel Rose, Giancarlo, Beatrice, all answered quan for number 9, and you are all correct. T-test for dependent samples is used for quantitative research. Last item, number 10, Pearson R or Pearson product moment correlation. Is it used for quantitative data analysis technique or qualitative? Number 10, okay, a lot answered quan. starting from Hazel Rose, Crishale, Andrea Giancarlo, Julia, Jane Wency, Charlie, Raf Radores, and a lot more. So Pearson R is, of course, a quantitative data analysis technique. So congratulations, class, for answering it all correctly. How did you find the activity, class? Was it easy or difficult? How were you able to classify the words? Or what helped you in classifying the words? And class, when do we appropriately use this data analysis technique? Kailan natin gagamitin si um, quantitative at saka si qualitative data analysis technique? All right? Take note, class, that each type of research, whether qualitative or quantitative, has its own distinguishing data analysis techniques. As student researchers, it is necessary that we know the meaning and purpose of these data analysis techniques. And class, this is what we're going to discuss in our tutorial session today. Let us start our discussion with the different data analysis techniques used in quantitative research. Because for our next tutorial session, we will discuss the different data analysis techniques used in qualitative research. All right? Quantitative data analysis technique, class, is divided into two. We have descriptive and inferential statistics. But first, let me talk about descriptive statistics. Descriptive statistics are used in describing a set of data. If you may recall in our previous tutorial session that in order for us to answer our descriptive research questions, like questions asking the profile of respondents in terms of age and gender, or to answer the question, like the question, what is the senior high school student's level of dengue knowledge? All right? To answer or analyze these descriptive type of research questions, of course, we will use descriptive statistics. Descriptive statistics includes frequency count, percentage, measures of central tendency, the mean, weighted mean, median, and mode, as well as the measures of variability, range, variance, and standard deviation. Let us start first with frequency counts. Frequency counts measure the number of times that an event or observation occurs. Example for frequency count is the counting of let's say number of male and number of female respondents in your study, or to know what are the respondent sources of information about dengue. Okay, since the answer to this question can be obtained through counting the students' responses as their source of dengue knowledge. Another descriptive analysis technique is through the use of percentage. Percentage is actually a part, no? It's a part of a whole distribution. Like if you want to know in your study how many percent are males or how many percent are females. All right? Another is the mean, or the computational average, or the average of the given data set. This is the most commonly used descriptive statistics in educational research. Like, in order for you to answer the question, what is the senior high school student's level of dengue knowledge? You need to obtain or measure the mean or the average score of the respondents based on the respondent score or the student score in a test about dengue, right? Then we also have what we call weighted mean. Okay, weighted mean can be used to know the perception of the respondents based on their answers in a Likert type or a Likert scale or a Likert type questionnaire. You may, kasi in a Likert type questionnaire or in a Likert scale, students, okay, their scores can be multiplied with the weights, no, in every descriptor or in every scale. For example, we multiply times 1, times 3, times 5. And then you get the weighted average. We also have the median, which is also called as the positional average. It is the middlemost value when data are arranged in ascending or descending order. Then the mode, also referred to as the nominal average, which is also known as the most common value or the value that appears most often in a data set. Like for example, to answer the question, what TV channel is the most commonly watched by senior high school students? Of course, that can be answered through the use of mode. And take note, class, that mean, median, and mode are measures of central tendency, while the most common measures of variability or measure of dispersion is the range, standard deviation, and variance. The range is just the difference between the largest and smallest values in a set of data, or the highest and lowest value in a data set. Next, or another measure of dispersion is the variance, okay? The variance is actually the squared value of your standard deviation. So the square root of your variance is just your standard deviation, wherein the standard deviation is the measure of dispersion of a set of data from its mean or from the average. In here, we can measure the homogeneity and the heterogeneity of the data, or we will be able to know whether the scores in the data set is homogeneous or not, no, through the use of the measure of variability or the measure of dispersion. All right. Now, to compute the descriptive statistics using the Microsoft Office data analysis tool pack, specifically in the Microsoft Excel, okay, what you're going to do is you're going to follow these steps. All right. So unlike in your statistics and probability class that you're going to really compute, no, manually the measures or the values to get for, let's say, to get the value for your mean, for your standard deviation, or for your variance. But in doing research, kung ato na siya i-apply, no, sa ato ang research, okay? So we have actually a lot of tools, no, or softwares that we can use, no, para yung gagawin natin is for analysis na lang po. All right? So when you're going to do or use the MS Data Analysis Toolpack, so first is you're going to click Data, then look for Descriptive Statistics, and click OK. Next is you're going to enter your input and output range, or you can just simply highlight the data for your input and output, then check Summary Statistics, and then click OK. All right? So last is you're going to click OK. So were you able to follow, class? So for you to practice, please try computing the descriptive statistics of your own study using this Microsoft Office Data Analysis Toolpack. All right? Now, what if you are asked, class, these questions? Or what if you will have these research questions in your study? Like, is there a significant difference between the first and second semester general average grade of STEM learners? Or is there a significant relationship between the preferred learning modality and the academic performance of senior high school learners in the new normal? Okay, what do you think is the essential statistics to be used in this type of questions? Ano pong gagamitin natin kapag nakakita tayo ng significant difference, significant relationships? Okay, these questions can be answered, masasagutan po ito ng inferential statistics or inferential statistical techniques through hypothesis testing. All right? So what is inferential statistics? In inferential statistics, data are analyzed from a sample to make inferences in the larger collection of the population. The purpose is to answer or test your research hypothesis. Thus, hypothesis testing is a procedure for making rational decisions about the reality of observed facts. Okay? A hypothesis, when used in plural form, is called hypotheses. No? Two or more hypotheses. Okay? Hypothesis or hypotheses is a proposed explanation for a phenomenon. It has two types. We have two types of hypotheses: null and alternative hypothesis. First step in hypothesis testing is you are going to state the null and the alternative hypothesis. A null hypothesis, denoted by H sub O, is a denial of existence of significant difference, effect, or relationship, or which states that there is no significant difference, effect, or relationship between or among variables. Actually, in simpler terms, it is the hypothesis that the researcher tries to disprove, no, in the study. On the other hand, alternative hypothesis, denoted by H sub A or H sub 1, is an affirmation of existence of significant difference, effect, or relationship, or which states that there is a significant difference, effect, or relationship among variables. Take note, class, that failure to reject the null hypothesis or H sub O does not mean that the null hypothesis is true or we are going to accept the null hypothesis. It only means that we do not have sufficient evidence to support the alternative hypothesis or the H sub 1. All right? And here are the statistical treatments that we can use to test for difference, test for relationship, and test for association. As you can see in this table that we have two types of tests, parametric and non-parametric tests. We will use non-parametric tests when your data potentially does not follow a normal distribution, or if your data is not, or at least not, interval in nature. Like for example, if your data is ordinal or you have a ranked data, and when there is no randomness of your samples. All right? So then, if that is the case, you will use non-parametric test. Pero kailangan muna natin i-explore. Alright? Kailangan muna natin i-explore ang lahat ng possibility before tayo gumamit ng non-parametric test. Kasi sa mga statistical treatments, pinaka makapangyarihan po ang parametric test. Maraming mawawala if gagamit tayo kaagad ng non-parametric test. Alright? So, let us say na na-meet natin yung lahat ng assumptions of using parametric tests. So, we will use t-tests, okay? In order to know the difference of two independent groups. T-test if given that the sample size is less than or equal to 30. Z-test if the sample size is greater than 30. Then we will use ANOVA or analysis of variance, right? If you have 3 or more independent groups. Pearson R to test the relationship of two variables, or Pearson product moment correlation. Okay, we can use Pearson R to test the relationship of two variables with an interval or ratio data. All right? Then, we also have simple and multiple regression to test for association. For the purpose of this tutorial session, let us say na na-meet na po natin lahat ng assumptions para gagamit tayo ng parametric test. Like, na-test na natin ang normality ng dataset natin gamit ang Kolmogorov-Smirnov test. Okay, that is, Kolmogorov-Smirnov test is a test for normality. And based from the results, it says that the data is normally distributed. Tapos, merong homogeneity o variance na din po tayo. Let us say, after doing Levene's test, okay, merong homogeneity, yung variance natin. Tsaka merong randomness, and your data are mutually exclusive or there is independence. And given that you are dealing with interval or ratio data with large data sets. So when all of these assumptions were met, so we can proceed to using parametric tests. All right? Another step in hypothesis testing is to determine the appropriate statistical technique to be used. T-tests of independent samples in which it determines whether the means or the averages of two independent groups differ significantly. For example, when you are going to compare a data or data is compared or the data compared are coming from two groups. Let us say male and female group. Or if you want to compare the scores of students using an intervention and the scores of students without using an intervention. So the appropriate test to be used is t-test for independent samples. Okay, meaning it can only be used in two unrelated groups. On the other hand, t-test of dependent samples determines whether the means of the two dependent groups differ significantly. This is also referred to as t-test for paired samples. In here, the data are coming from one group. For example, you want to compare the score before and after an intervention. Or if you want to compare the pre-test and post-test scores of one group, let us say the experimental group. So the dependent t-test or paired sample t-test can be used to test either a change or a difference in the means between two related groups. All right? To determine if there is a significant relationship between variables or to test the correlation between variables, we can use Pearson's R or Pearson product moment correlation, which is used to measure the strength or magnitude and the direction of the linear relationship of two quantitative variables. Take note, two quantitative variables. So that can be interval or ratio data, right? The Spearman rank correlation or Spearman's law evaluates the monotonic relationship between two ordinal variables or variables that can be ranked. Okay. Remember, class, that the last step in hypothesis testing is to write the conclusion. But we cannot decide whether to reject or do not reject the null hypothesis or the H sub O without using these methods. First is the use of the p-value method. All right? If the p-value, okay, take note, if the p-value is less than or equal to the level of significance or alpha, wherein in educational research, the commonly used level of significance is 5% or 0.05. So if the p-value is less than or equal to 0.05, then we reject the null hypothesis. It means that the difference or the relationship is significant. However, if the p-value is greater than the level of significance, or if the p-value is greater than 0.05, then we fail to reject the null hypothesis. It means that the difference or the relationship is not significant. All right? The second approach that we can use in our decision making is the use of the critical value approach. If the computed value, take note, if the computed value, whether T computed or Z computed, is greater than the tabular or critical value, then we reject the null hypothesis. So opposite po ito ng p-value approach. Okay? So take note ha, kanina, if lesser than or equal to if the p-value is lesser than or equal to the level of significance, we reject the null hypothesis. If using the critical value approach, okay, given that, okay, if the computed, t computed, or z computed, kabaliktaran, is greater than the tabular or critical value, then we reject the null hypothesis. It means that the difference or relationship is significant. However, if the computed value is lesser than or equal to the tabular or critical value, then we fail to reject the null hypothesis. It means that the difference or relationship is not significant. Right? Now, in order for us to interpret our relationship or the relationship of variables, we can use this interpretation table for correlation using Best and Kahn 2006 and Cohen 1992. So for Best and Kahn 2006, no, if your computed R or computed correlation coefficient ranges from 0 to plus minus 0.20, that is negligible, plus minus 0.20 to positive negative 0.40, that is low, plus minus 0.40 to plus minus 0.60, that is moderate, plus minus 0.60 up to plus minus 0.80, that's substantial, plus minus 0.80 up to plus minus 1.0, meaning high to very high relationship. Using Cohen's 1992, okay, table for correlation, we can have negative 0.3 to positive 0.3. There is a weak relationship. Okay, negative 0.5 to negative 0.3 or 0.3 to 0.5. There is a moderate relationship. Negative 0.9 to negative 0.5 or 0.5 to 0.9, there is a strong relationship between the variables. Negative 1.0 to negative 0.09 or that is negative 0.9 or 0.9 to 1.0, there is a very strong relationship. Now, using Mendenhall, Beaver R, and Beaver B 2013, okay, to test if the result for correlation is significant or the relationship is significant or not. So we can use this table for our interpretation. Now, if the p-value is less than 0.01, then our interpretation is highly significant. P-value is greater than or equal to 0.01, or it ranges from 0.01 to 0.05. So our relationship is significant. Now, if the p-value is greater than 0.05, then the relationship is not significant. All right? Now, let us try using these tables in our example. Let's have a problem. The given problem says, a dietetic student wanted to look at the relationship between calcium intake and knowledge about calcium in sports science students or those students in the special program for sports. All right. Now, we have here our data. Here are the knowledge score or the score of students obtained in a test about calcium intake or the knowledge about calcium, given that we have 20 respondents out of 50 items. So here are their scores. And we also have the calcium intake, the calcium intake of the same set of respondents, those 20 respondents in the same order. Okay, from 450, 1050, then we also have 1085. All right. Now, we will not be manually computing, right, the uh, value for the correlation. All right. Now we have the Microsoft Excel for us to do that. Okay, so what we're going to do, what we're going to focus is how we're going to interpret. If we already have the result, if we already have the data, how are we going to interpret that? No? Kasi walang gamit po if we know how to compute for the correlation, we know how to compute for the test for let's say test for means, no? If walang gamit po if we don't know how to interpret or how to analyze these results. Okay? Kasi maraming students na nagtatanong po sa akin, "Sir, paano po given this data, ano pong gagawin namin? Ano po yung interpretation po namin?" So dapat as student researchers, so dapat ito pong pina-practice natin ngayon, no? Hindi na po yung basic of the computations, no? Dapat yung paano natin mai-interpret given the result of your computation. All right? Now, let's say that our research question for that problem is there a significant relationship between calcium intake and knowledge about calcium in sports science students? So, we can create, so kailangan importante ito, no? Sa hypothesis testing, dapat ma-determine natin or ma-indicate natin yung null at saka alternative hypothesis natin sa study. Okay, so given that research question, we can have our null hypothesis to be there is no significant relationship between calcium intake and knowledge about calcium in sports science students, or equivalent to saying the correlation coefficient R is just equal to 0. Now, we have the alternative hypothesis, the opposite of the null hypothesis. So we state there is a significant correlation or relationship between calcium intake and knowledge about calcium in sports science students, equivalent to saying R, or the correlation coefficient, is not equal to 0. Right? So, therefore, what is the correlation coefficient R? So, if we're going to use the Microsoft Excel, we're going to type or key in our data and then look for Pearson R. Okay? So, we will have this result. Okay? Knowledge score, the relation, this is our correlation matrix. All right? So, knowledge to knowledge score, of course, that's a perfect relationship, 1. Calcium intake to calcium intake, of course, that is 1. So, ang ating gustong malaman is ano yung relationship ng knowledge score to calcium intake. So, we can see it here, that is 0.88. Okay? So, we will just use the 2 decimal places. So, approximately equal to 0.88. Now, what is the nature and strength of our relationship given that the correlation coefficient R is equal to 0.88? So therefore, we will use our, okay, wait. If we go back to Best and Can, okay, Best and Can 2016, merong typo dito, and Cohen's 1992. So 0.88 is actually, that is high to very high. And then using Cohen, that is, there is a strong relationship. All right? So, can you take note, no? Dapat importante yung table natin, no? Yung table for interpretation of the correlation or the relationship. All right? What is the p-value? Okay, so sa result natin sa Microsoft Excel, the p-value is less than 0.001. So using the p-value, is the relationship significant or not? So we go back to Mendenhall's et al. Interpretation table. Okay, we will try to look if, given the p-value, ano po yung decision natin? Okay? Or ano po yung conclusion natin? Now, the p-value daw is less than 0.001. So I think that is 0.00000 something, no? Raised to the nth power. Okay. Now, so if the p-value is less than, okay, 0.001, therefore, that is highly significant. All right? So using Mendenhall et al. 2013, okay, therefore we can say that the relationship is significant. Okay? Kaya in here, meron tayong less than 0.01. How much more if that is 0.001? All right? Now, what is your decision against your null hypothesis? So, given that the relationship is significant, okay, using the Cohen's 1992 interpretation as well as using the Mendenhall's interpretation table, therefore we can say that the null hypothesis is stating that there is no significant correlation or relationship between calcium intake and knowledge about calcium in sports science students or students in the special program for sports, equivalent to saying R is equal to 0, is rejected. Okay, so we reject the null hypothesis. All right, so here is the EPA style of reporting the correlation or the relationship. Okay, given R, okay, R of 20, meaning you have 20 samples, is equal to 0.88. Okay, your correlation coefficient is equal to 0.88, and your P is less than, or P value or probability value is less than 0.001. So we can write knowledge about calcium and calcium intake are strongly and significantly correlated. So meron tayong magnitude at magnitude meaning strong yung relationship. Tapos na-determine natin that the relationship is significant. Okay? So R of 20 is equal to 0.88 or P less than 0.001. The P value associated with the test statistic is highly significant, meaning there is a sufficient evidence against the null hypothesis. Hence, it is rejected. It implies that in the population, high calcium intake is associated with high knowledge about calcium. Alright? So, naintindihan po ba yung interpretation natin? Alright, now aside from determining if the relationship or the correlation is significant or not, or if the relationship is strong, no, meaning we determine the magnitude of the relationship, we can also determine the direction of the relationship, whether there is a positive correlation or a negative correlation. Alright? So, using pa rin your Microsoft Excel, so as you can see in the figure, okay, meron po sa itaas ng ating dito po, as you can see, no, meron tayong scatter plot. Okay. So, highlight lang natin yung ating data, okay? Yung X natin at saka Y. Okay? Yung X natin is the knowledge score, okay, of 20 respondents out of 50 items. And then your Y, ang Y natin ay yung Y value, okay, nandito sa okay, vertical axis is yung calcium intake. Okay, so highlight din natin and then click, no, this one, this is scatter plot. So we can have that figure. All right? So kung okay, let's have a closer look of that figure. Okay. So, we have this, okay, calcium intake and knowledge about calcium, right? So, in the x-axis, we have the knowledge score, okay, out of 50 items, okay? And then, the calcium intake of 20 students, all right, in the y-axis. So, if you go back to our, this one, this is the scatter plots and correlation examples, okay? So, if the scatter plot will look like this, meaning there is a perfect positive correlation. If it looks like this, okay, not perfectly, but closer yung dots from left to right, it is increasing. All right? So there is a high or highly positive correlation. Okay? Kung kabaliktaran, no? If it is decreasing, no? From left to right, it is decreasing. Therefore, there is a high negative correlation. Right? Now, for low positive correlation, as you can see, hindi masyadong dikit yung mga dots natin. So there is a low positive correlation, but still, meron pa ring direction. It is going up, no? From left to right, the dots are going up. So there is still pa rin a positive correlation. Pero if the dots from left to right is decreasing, so there is a low negative correlation. Now, for no correlation, as you can see, wala po tayong direction na madodraw. Okay? So that will be the example of a scatter plot of the relationship of the variables wherein there is no correlation. Parang wala tayong madodraw na pattern. Okay? So therefore, given our scatter plot, this one, so therefore we can say that there is a high positive correlation. As you can see, makakadraw po tayo ng straight line from left to right, no? Increasing from left to right. Okay? So there is a high positive correlation. So what does it mean when there is a high positive correlation? Meaning there's a high positive correlation between the calcium intake and the knowledge about calcium among students in the special program for sports. So ano pong ibig sabihin yan? If there is a high positive correlation, that implies that if their knowledge about calcium increases, right, then they will more likely increase also their calcium intake. And the other way around. Alright? Naintindihan po ba? Okay. Now that you have gained a clear understanding on our topic today, let us apply what you've learned by answering the following activity. You are going to write the appropriate data analysis technique or techniques, okay, to be used for the following problems. Please write your answers in our live stream's comment section. All right? Are you ready? Number 1. Teachers' perception on the implementation of senior high school using 4-point scale. What data analysis technique, quantitative data analysis technique can we use in this research? Okay, again, number 1, teachers' perception on the implementation of senior high school using 4-point scale or Likert scale. Jane Wency Tadora answered descriptive statistics. That is correct, Jane Wency. Specifically, that is, we can use weighted mean for that. All right? Or meron specifically for to answer the perceptions of the teachers using a 4-point Likert scale. So we can use weighted mean. All right? Now, for number 2, the relationship between the first and second semester grades of STEM learners. Again, number 2, the relationship between the first and second semester grades of STEM learners. What quantitative data analysis technique can we use for item number 2? So since we are looking for the relationship between the variables, all right? Correct, Stacy. Very good. Pearson R. Micah Hindoy answered inferential statistics. That is correct also. Specifically, we will use Pearson R or Pearson product moment correlation. Then, for last item, number 3, the difference between pre-test and post-test results in mathematics. Okay? Ano pong gagamitin natin? Okay, of course, since we want to know the difference between the pre-test and post-test results in mathematics, of course, we will be using inferential statistics. So, specifically, what data analysis technique under inferential statistic po? For number 3. Again, pre-test and post-test results. Meaning, same group, yung kukunan natin ng difference, okay? Same group, okay? Then we look into the difference between their pre-test and their post-test scores. So anong gagamitin natin na inferential statistics? Micah Hindoy answered t-test, correct. But Micah, meron tayong dalawang type of t-test. Meron tayong t-test for independent samples at t-test for dependent samples or t-test for paired samples. Alin doon yung gagamitin natin for item number 3? Again, meron tayong t-test for independent samples, right? T-test for dependent samples. Hazel Rose answered t-test for dependent samples. Sir, that is correct. Or dependent t-test answered by Maria Gloria. That is correct also. Or we can say, we can use t-test for paired samples. Okay? T-test for dependent samples or dependent sample t-test or paired sample t-test. Alright? Bakit paired sample? Because yung scores natin ay galing sa isang grupo lang. Okay, then we try to look into their pre-test, the difference between their pre-test and post-test scores. Alright, naintindihan po ba? Then we go to number 4, item number 4. Okay, you are going to write the letter of your answer in the comment section. Alright, a researcher wants to find out if time spent on Facebook and friendliness are correlated. Correlation analysis revealed a correlation coefficient of 0.88 and a p-value of 0.052. Given this, therefore we can say that the relationship found is blank. A, highly significant. B, not significant. C, significant. D, very significant. Miggy answered B, sir. Not significant. Maria Gloria Judea also answered letter B. And you are correct. Okay. Using Mendenhall's table for correlation interpretation, we have, okay, since the p-value is 0.052, so it falls less than, okay, less than 0. Greater than 0.05. Okay? 0.052 is greater than 0.05. Therefore, we say that the relationship or the correlation is not significant. Very good. Last item, right? You are going to interpret the following correlation coefficient using Cohen's interpretation 1992 for the given R value, or the given correlation coefficient. The correlation coefficient is 0.70. Okay? So what will be the magnitude or the strength of the correlation given or using Cohen's 1992 interpretation table? So you write the word, no, in the comment section. Is there a weak relationship, moderate, strong, or very strong? Miggy answered strong. Stacy also answered strong. Very good. So given the correlation coefficient of 0.70 and using Cohen's interpretation table, since 0.70 falls in the interval 0.5 to 0.9, therefore we say that there is a strong relationship or there's a strong correlation between the given variables. Alright? Naintindihan po ba? May tanong po ba tayo, class? Alright? Now, for your assignment, since this is 3 I's, you are going to apply the appropriate data analysis technique that you are going to use given your research questions. Okay? Diba? Meron na tayong research questions that you have formulated from the previous sessions. Now, following also the guidelines presented in the tutorial class, kindly post, okay, in your FB timeline and use the hashtag ETUlay III analyzing data. Again, the hashtag is #ETUlay III Analyzing Data. At sa mga hindi po makapanood or nakapanood ng ating weekly live tutorial sessions, you may follow me sa aking Wakelet account na nakalagay sa inyong mga screens. Or pwede ding scan, okay, ang QR code na nasa inyong mga screens. Ang ating recorded videos ng ETUlay tutorial sessions in inquiries, investigations, and immersion are compiled in our Wakelet account. At iyan po ang ating online tutorial sa linggong ito. See you po in our next tutorial session, same time, same day. This has been your ETUlay tutor, Sir June, na nagiiwan ng katagang, "The research of today shall speak the innovations of tomorrow." Thank you and happy researching!
Mga guro at magulang, ating pagtulungan, kabataan ay turuan natin. Kahit na nasa tahanan, pag-aaral ay tutukan, oras at kasanayan ay ilaan. Sulong edukalidad, magbago man ang panahon, ipagpatuloy ating layunin, patatagin ang edukasyon. ETUlay ang gabay sa pagkatuto, ETUlay edukasyon itatawid sa iyo. ETUlay paaralan di lalayo sa iyo. ETUlay sa makabagong panahon, ETUlay para sa kabataang Pilipino. Kayo ba'y may katanungan at hindi maunawaan? Kami ang gabay at tulay na magtuturo sa'yo. Sa tulong ng teknolohiya at maging ng social media, paaralan ay kusang lalapit sa'yo. Tulong edukalidad, supuin maling impormasyon, katotohanan nating ituro, paunlarin ang edukasyon. ETUlay ang gabay sa pagkatuto, ETUlay edukasyon itatawid sa iyo. ETUlay paaralan di lalayo sa iyo. ETUlay sa makabagong panahon, ETUlay para sa kabataang Pilipino. ETUlay ang gabay sa pagkatuto, ETUlay edukasyon itatawid sa iyo. ETUlay paaralan di lalayo sa iyo. ETUlay sa makabagong panahon, ETUlay para sa kabataang Pilipino. ETUlay, ETUlay sa kabataang Pilipino. ETUlay, ETUlay sa kabataang Pilipino. ETUlay, ETUlay sa kabataang Pilipino.